Hello, for today's video lecture we're going to be talking about free body diagrams. So the first question is, why are we going to use free body diagrams? Well, a free body diagram is a simplified version of a physical system that engineers are going to use, particularly in mechanics problems, as a starting point for analysis. So usually we've got some physical system that's our actual problem that we're looking at. This might be the problem from your book. And then we turn that physical system into a free body diagram. The free body diagram is a simplified version of the situation. It's still going to be very visual. From our free body diagram, we can then generate our equilibrium equations for statics problems, or our equations of motion for dynamics problems, and that's going to be math. And so between the math and the physical system, our free body diagram is an intermediate step that kind of helps us get to this math part of the problem. Alright, so creating a free body diagram, what do we do to create that? Step one is going to be, we're going to draw a picture of the body being analyzed, separated from all of the background objects. So we're going to free the body, as where a free body diagram comes from, we're going to free the body from all of its surroundings. So we've only got our object that we're analyzing. Next, we're going to draw in any forces acting on the body. So there's lots of different types of forces we can have. We can have normal forces, and we're going to have that anywhere the body was contacting something else, we're going to have a normal force. We're going to have gravitational forces. If the body has some weight, it's going to have a gravitational force acting on it. It's going to have friction forces for any rough surfaces that it's in contact with. It's going to have tension in any cables or wires that we kind of got rid of when we freed our body. So all of these are pretty common. There's a lot of other types of forces, and a lot of statics is determining the magnitude, the direction, and how these forces behave. So we're not going to get into that too much. And then once we have all the forces acting on the body, we're going to add angles for any force vectors. So forces have both a magnitude and direction. And we're going to add any key dimensions, and those dimensions are going to be particularly important when we're dealing with moments. Alright, so going to some of these types of forces. Let's start with the gravitational force. So the gravitational forces are forces that are present due to the weight of an object. And we'll usually model these as a point force acting downward, and downward in this case is towards the center of the Earth. At least this is going to be at kind of sea level on the surface of the Earth. And it's going to be acting at the center of mass of the body. So we've got our box, our center of mass would be right kind of geometric center of that. And it's going to be acting downward. So we put in our force vector like that. And in an English system, we're usually given weights. And so if I have a 60-pound box, this gravitational force is going to be 60 pounds going straight down. And if I have metric system, we're given a mass. And so a mass is different than a weight. So if I've got a 60 kilogram box, I need to multiply that by the acceleration due to gravity, or g. And that g for the metric system is 9.81, and one of the units we can use for this is newtons per kilogram. So 60 kilograms times 9.81, 588.6 newtons. That is the force, or the weight force that is acting on my 60 kilogram box. Alright, next we've got normal forces. And a normal force, also sometimes called a reaction force, is the force that prevents two bodies from occupying the same spot, same place at the same time. So anything in contact is going to have normal forces kind of keeping those bodies separate. Alright, so they will always act perpendicular or normal to the surfaces in contact. That's where the normal force name comes from. And so if we have something like this, we've got maybe a barrel, and this would be in like a hand cart holding this up. So I've got my gravity force pulling it down, and then the normal forces, those are both perpendicular to those surfaces that it's in contact with. So it's always going to be perpendicular for my normal forces. Another important thing to look at with normal forces is the kind of types of forces, the normal forces that exist between connected bodies. So these connections can exert normal forces and even moments that are going to kind of prevent motion in certain directions. And so this diagram over here, if I've got something like a roller, and so this would be like a wheel on the end of something, that wheel, just like I had something on a surface, it allows motion back and forth. It kind of allows this body to rotate, but it prevents motion. I can't push the wheel into the ground. And generally, unless I'm pulling the whole body up, it's going to have some normal force just in the y direction. If I have something a little more constraining, like a pin joint, so a pin joint allows for rotation. This would be like a hinge on a door, but it prevents motion to the left and right, and it prevents motion up and down. And so I've got two normal forces, two reaction forces there for the two ways that this joint prevents motion. Finally, if I do something like sink a post into a ground, that's going to be a solid connection. It'd be like something welded to another body. And in that case, I can't have any motion. I can't move back and forth. I can't move up and down. I can't rotate the body. And so each way I can't move, I'm going to have some reaction force, some normal force or normal moment that is preventing that motion. Next, we'll talk about friction. So friction forces will act between any two surfaces that are in contact, just like we have the normal forces. But they are going to kind of prevent sliding. They're not preventing the objects from kind of moving one into the space of the other. They're preventing the two objects from sliding relative to one another. And it can be a complex interaction, but for now, in early stages, we usually talk about two types of surfaces. We're going to talk about smooth surfaces where no friction exists, and we're going to talk about rough surfaces where no matter how hard I push on something, the friction is large enough that it's going to prevent that motion. And so with something like a smooth surface, if I just got kind of the leg of maybe a chair here, if it's a smooth surface, I assume I only have this normal force that's just perpendicular to my surface. Whereas on a rough surface, I've got the normal force preventing me from kind of falling into the ground, and the friction force is going to be whatever is large enough to prevent it from sliding back and forth either way. Last type of common force we're going to talk about for today is a tension force. So cables, ropes, other flexible connections will often carry tension forces. You can be supporting something. So these forces will always be pulling in the direction of the cable itself. If we kind of remove the cable, we put a force in that same direction as the cable was. And these are always going to be tension forces. So you can never push something with a rope. And so say I've got a stoplight. It's got two cables holding this up. And those tension forces, they're going to be in the direction that I had the cable originally. So tension 1, tension 2, and those angles are going to match up with what I had over here. And again, they're always pulling, they're never going to be pushing on a body. If you find you're pushing something with a rope, you've done something wrong in your problem. All right, so going back to our kind of process, we want to draw a picture of the body being analyzed. We're going to separate that body from all of the things in the background. We want to draw in any forces that are acting on the body. And again, those can be normal, gravitational, friction, or tension forces, in addition to other types of forces that are kind of not quite as common in mechanics. And then we're going to add in any angles, any dimensions that are kind of relevant to our problem. All right, so let's look at a specific scenario. So say we've got a man that's standing on this ladder here. What would we want to do to draw a free body diagram of the ladder? Step 1 is going to be to draw a picture of the ladder itself. So we've got this ladder over here. I'm not analyzing the man, I'm not analyzing the floor, so I don't draw in any of that stuff. And now I want to start adding forces. So some things I can think about. The ladder probably has a weight to it, so we're going to draw in that gravity force acting on the center of mass, which I'm going to assume for this is going to be kind of the center of the ladder. The man is going to be exerting a normal force on this. So the man is in contact with the ladder, so he's going to be pushing down on the ladder. Both of the walls, I have normal forces perpendicular to the wall up here, a normal force perpendicular to the wall down here. So there's two more normal forces there. And then assuming I made the assumption that I'm going to have a rough surface down here on the floor, a smooth surface up here. So anywhere I have a rough surface, I'm going to have a friction force. And that friction force is parallel with the surface itself, and it's going to be preventing the motion that would occur. And so if I think about if all of this was smooth, if both of these surfaces were like ice, the ladder would kind of slide out that way. And so to prevent that sliding, this friction force has to be going the other direction. This friction force is what's preventing it from sliding out that way. So here I've gone from an original problem diagram to my free body diagram right here. From this free body diagram, I would go on to create my equilibrium equations or equations of motion, and you kind of use math to solve for the magnitudes of all these forces. So with that, that's all I have for free body diagrams. Oh, sorry, one last thing. I always want to remember to add in those dimensions. I've got kind of distances, I've got angles there. And with that, that's all I have for free body diagrams. Thank you for watching, and I hope to see you again.